All right, for this lesson, we're going to be investigating the derivatives of the exponential and logarithmic functions. I'm going to start by just giving you these four derivatives straight up. Here they are. Number one, if you're taking the derivative with respect to x of e to the u, the derivative is e to the u times derivative of u with respect to x. Number two, if you're finding the derivative with respect to x of the natural log of u, the derivative is 1 over u times the derivative of u with respect to x. Number three, if you're finding the derivative with respect to x of the log base a of u, the derivative is 1 divided by u times the natural log of a times the derivative of u with respect to x. Some students will, over the years, have said, that looks like the word ulna. I'm going to memorize it as 1 over ulna, which is fine if that helps. And number four, the derivative with respect to x of a to the u, where a is a constant, is a to the u times the natural log of a times du dx. In another video, part 2 of this video, I'm going to prove why these are what they are. But for now, we're just going to take them at face value, and we're going to work through the 9 examples here in the packet using them. So here we go. Example 1. Given y equals e to the x, find the derivative of y. Okay, well, if you use formula number 1 from up top, you're going to see that dy dx, it says that the derivative of e to the u is e to the u, so this right here, this x is my u, e to the u times the derivative of u. Well, the derivative of x is 1. So e to the u times derivative of u gives me a final answer here of e to the x. Pretty simple. Example 2. Given y equals natural log of x, find the derivative of y. Okay, this is going to be formula number 2 from up top. This right here is my u, it's just an x. So derivative of y with respect to x will be 1 over u times the derivative of u. Well, the derivative of x is just 1. So the final answer, just 1 over x. Example 3. Given y equals log base 2 of x, find the derivative of y. This is going to be formula number 3. Now for this one, I'm going to label 2 things because this formula has an a and a u in it. So the 2 down here is my a, and the x is my u. So upstairs it says log base a of u, but now I'm getting specific. My a is 2, log base 2 of x. So the derivative, if I follow the formula says you take 1 over u, which is x, natural log of a, which is 2, times the derivative of u, and the derivative of x is 1. So the final answer would be 1 divided by x times the natural log of 2. Just kind of plugging and chugging through these formulas. Number 4, given y equals 2 to the x. Well, 2 is a constant, so I'm looking at formula number 4 from up top. This says that dy dx equals, okay, this 2 right here looks like my a, and the x looks like my u. So a to the u, 2 to the x. So the right side of the formula says that the derivative is a to the u times the natural log of a, which is 2, times the derivative of u, and the derivative of x is 1. So final answer here, 2 to the x, natural log of 2. Example 5. Given y equals the natural log of x squared minus x minus 2, find the derivative. Okay, this is going to be formula number 2 from up top, because it's natural log. This whole quantity is my u, the natural log of u. So derivative of y with respect to x, according to the formula, is 1 all over u, so I'm going to copy that whole expression down, times the derivative of u. Using the power rule and the linear function rule, that derivative would just be 2x minus 1. So my final answer I'll take the 2x minus 1 times 1 and just write that as 2x minus 1 all over x squared minus x minus 2. Okay, let's turn to the second page. There's a few more examples over there. Example 6. Given y equals e raised to the square root of x, find the derivative. Okay, well, dy dx. This is going to be formula number 1, e to the u. This right here is my u. So the derivative is e to the u times the derivative of u. So I have to find the derivative of the square root of x. So if I rewrite square root of x off to the side as x raised to the 1/2 power, then I know from prior knowledge the derivative of x to the 1/2 power by power rule is going to be 1/2 x raised to the negative 1/2. And if I clean that up, that will be 1 over 2x to the positive 1/2, or 1 over 2 square root x. So back to this, my derivative is e to the u times the derivative of u. I'm just going to recopy 1 over 2 root x here. Final answer then, if I clean this up, e to the square root of x times 1 is e to the square root of x all over 2 root x. That'll be my final answer. All right, example 7, y equals 3 raised to the 5x. Find the derivative. That is going to be back to formula number 4, since 3 is a constant. So this right here, the 3 is my a raised to the u. 5x is my u. So a to the u, so the derivative of a to the u is a to the u times the natural log of a times the derivative of u, which is 5. So the derivative of 5x is 5. And I would just leave it like that, because if you bring the 5 to the front, I think that's almost going to look more awkward than this does. So let's just call this our final answer. Example 8, given y equals log base 10 of x to the 4th plus 13. Okay, this is going to be formula number 3, which is log base a of u. So u is all this stuff in parentheses. So the derivative of y with respect to x is going to be 1 over u natural log of a times the derivative of u, which is 4x to the 3rd. Derivative of u. So my final answer, 4x to the 3rd times 1 is 4x to the 3rd over, just going to leave this as x to the 4th plus 13, natural log 10. That'll be my final answer. Okay, example 9, the last one here. I'm calling this a special case. If you look at this problem, y equals x to the x, that is not a formula we know. It's not the power rule, because if this were the power rule, this guy up here, this x, would be a constant, like x squared, x to the 3rd. And it's not number 4 from this lesson, because if it were a to the u, the base would be a constant. So it doesn't fit any of the rules we've studied in this chapter, and that's why it's a special case. You actually have to manipulate this problem in order to be able to find the derivative of it, and it's a little strange what you do. You actually take the natural log of both sides of the equation. So you're going to have to think back to your prior knowledge on natural logs. So if I take the natural log of y, that's ln of y, and if I take the natural log on this side, I'm going to have ln of x to the x. Now there is a property of logarithms that says that when you have the natural log or the regular log of a base raised to a power, the exponent can come down to the front. So my next line will be ln of y equals x, ln of x. Now I can find the derivative by implicitly differentiating and using the product rule, where this is my u and this is my v. So on this side, the derivative of the ln of y, now we have to think back on the front page to formula number 2. The derivative of the ln of u is 1 over u times the derivative of u. The derivative of y is 1, but since we're implicitly differentiating, we also tack on dy dx equals. Here we're going to use the product rule. First times derivative of second. This is also formula number 2 from the front page. The derivative of the ln of u is 1 over u times derivative of u. So that's the first times the derivative of the second plus the second times the derivative of the first, which would be 1. Cleaning this up, 1 over y times 1 is just 1 over y dy dx equals x times 1 over x times 1 is just 1, plus ln of x times 1 is just ln of x. To solve for dy dx, I'm just going to multiply both sides by y. That'll cancel these out and leave me with dy dx equals y times 1 plus natural log of x. To finish this off, in order to not have my derivative with a y and an x, since I don't have to, I'm going to go all the way back to the original problem. You see that y is equal to x to the x power, so I'm going to replace this y with that and write my final answer as x to the x power times the quantity 1 plus natural log of x. So that is why it's a special case. You have to natural log both sides and then use formulas from the front page in order to get to the derivative. Okay, thanks for watching. Oh, one more thing. In part 2 of this video, I'm going to go to the next page and show the why. Where did these formulas come from? We're going to do the proofs in the next video. But for tonight, you can do your homework. Your homework tonight is numbers 1 to 10. You got the first 6 here, 7, 8, 9, and 10 here. Just using your formulas, these will be just like the examples I showed you. And the answer key is on the back. So you'll be able to check your answers and know if you're right or wrong. All right, now we're done. Watch part 2 for the proofs.